Hello everyone, welcome to my channel Regas Gurukul. In our previous video, we have learned the first two types of chemical reactions. In this video, we are going to cover the other three types of chemical reactions, that is displacement, double displacement and redox reactions. So let's begin. Starting with the displacement reaction. The reactions in which a more reactive element displaces a less reactive element from its compound are called displacement reactions. Such reactions are also named as single displacement reactions. Let's say an element A reacts with compound BC. Here A is more reactive than B. So A will displace or push off B and combine with C, and we will get AC and B as the products. Now, how do you know that one element is more reactive than other? From the reactivity series. Let's first look at the metal reactivity series. Here, the metals are arranged in the decreasing order of their reactivity. Metals at the top are the most reactive. As we move down the reactivity series, the reactivity decreases. For example, potassium is the most reactive and gold and silver are the least reactive elements or metals. I know you must be wondering, why is hydrogen placed in the metal reactivity series? The answer is hydrogen is also electropositive in nature, just like the metals, as it can also form hydrogen ion by releasing its electron. Let's look at this reaction. Here, zinc is more reactive than iron, so it displaces iron and we get zinc sulfate and iron. During this reaction, the color of the solution changes from green to colorless. From exam point of view, if possible, please try to remember the colors of the chemicals. It will be very helpful for you. Let's try predicting the next reaction. Suppose an iron nail is placed in a blue colored copper sulfate solution. Then after some time, you will notice that the color of the solution becomes green. Why? Because iron, being more reactive than copper, displaces it from the copper sulfate solution to form ferrous sulfate, which is green in color. Again, since copper is being deposited here, a reddish brown colored deposit is formed on the iron nail. Now, what will happen if we consider the opposite reaction? That is, when a copper base is placed in ferrous sulfate solution? Correct, there will be no reaction because copper is less reactive than iron and so it cannot displace iron from its solution. Remember, the metals above hydrogen in the reactivity series can displace hydrogen gas from its solution. For example, if you add some zinc granule pieces in dilute sulfuric acid, then along with the formation of zinc sulfate, a gas will be evolved. If we try to burn the gas, it will produce a pop sound, which will prove that the gas is nothing but hydrogen. Here, since zinc is placed above hydrogen, it can displace hydrogen gas from its solution. Remember, displacement reactions can also take place in nonmetals. For nonmetals like halogens, the reactivity series looks like this. Here, fluorine is the most reactive and astatine and iodine are the least reactive halogens. For example, when chlorine gas is passed through potassium bromide, chlorine being more reactive than bromine displaces it and forms potassium chloride along with the evolution of bromine gas. This evolution of bromine gas will change the color of the solution into yellow or orange. Remember the key point for displacement reaction. A more reactive element displaces a less reactive element from its solution. Moving on to the next reaction, double displacement reaction. Here, two compounds react together and exchange their ions to produce two new compounds. Let's say we have compounds AB and CD. Suppose the positions of A and C are exchanged, then we will get CB and AD as the products. So this will be an example of double displacement reaction. Remember, such reactions mostly take place in ionic types of compounds and in aqueous solutions. Now, do we need to use the reactivity series for double displacement reaction also? The answer is no, because here no such competition for displacement takes place. Here only simple exchange of ions take place. For example, when two colorless solutions of potassium iodide and lead nitrate are mixed together, we will get a yellow precipitate. Why? Because in this reaction, the reactants are lead nitrate and potassium iodide. Lead nitrate has lead and nitrate ions and potassium iodide has potassium and iodide ions. When the positions of the potassium and lead are exchanged, then we will get lead iodide, which will form the yellow precipitate along with the formation of potassium nitrate. Remember, you need to exchange only the cations or the anions, not the both, or else you will get the same reactants again. Moving on to the next reaction. Suppose sodium hydroxide reacts with hydrochloric acid. As we know, sodium hydroxide has sodium ion and hydroxide ions, and hydrochloric acid has hydrogen and chloride ions. If sodium and hydrogen ions exchange their positions, then sodium ion will combine with chloride ion to form sodium chloride, and the combination of hydrogen ion and hydroxide ion together forms or leads to formation of water. Such types of reactions are also called neutralization reaction. Why? Because here, as we can see, the base, which is sodium hydroxide, is neutralized by the acid, which is hydrochloric acid, to form salt and water. This is the other type of double displacement reaction. Here, copper and hydrogen ions are exchanged to form copper sulfide, which will form the black precipitate along with the formation of sulfuric acid. Let's see the basic difference between displacement and double displacement reactions. In displacement, one element and one compound react together to form the products. But in double displacement, both the reactants are in the compound form. In displacement reaction, the reactivity series is applicable, but in double displacement, it is not applicable. In displacement, single or one only displacement takes place only once, but in double displacement takes place twice. Double displacement mostly takes place in aqueous solution. Moving on to the last reaction, redox reactions. It stands for reduction and oxidation. The reactions in which both the reduction and oxidation take place simultaneously are called redox reactions. Let's understand these two terms. Reduction is the addition of hydrogen and oxidation is the addition of oxygen. Similarly, reduction can be also defined as the removal of oxygen and oxidation as the removal of hydrogen. Reduction can be also the addition of non-metal and oxidation is the addition of metal. Reduction is the removal of metal and oxidation is the removal of non-metal. Let's take this example. Here copper oxide reacts with hydrogen. In this reaction, oxygen is being removed from copper. So, this is a reduction reaction and copper oxide is being reduced here. Again, after the reaction, oxygen is added to hydrogen. So, hydrogen is being oxidized here. Now, since hydrogen helps copper oxide to remove oxygen from it, it acts as a reducing agent. Again, since copper oxide is helping hydrogen by giving out its oxygen to get oxidized, so copper oxide acts as an oxidizing agent. Remember, oxidizing agent itself undergoes reduction, but the reducing agent itself undergoes oxidation. Moving on to the next reaction. Here, iron oxide reacts with aluminium, and after the reaction, oxygen is removed from iron by aluminium. So iron oxide is being reduced here and aluminium is the reducing agent. Again, after the reaction, oxygen is added to aluminium, so aluminium is being oxidized, and since iron oxide is providing its oxygen to aluminium, so it will act as an oxidizing agent. Hope this video is helpful for you. Do leave a like. Make sure to comment. Please subscribe to my channel and press the bell icon for further notifications.